All right, we're going to start Unit 7, and it is going to start with Lesson 1, which is the theory of plate tectonics. By the end of this lesson, you should be able to describe the historical development of the theory of plate tectonics. Of course, page 345 are those questions that you can start with and answer on your own, so I'm going to skip that. So let's go to page 346. And I'm going to read through, and then we're going to go back and highlight the things that I want you to pay special attention to. First subject in this lesson is continental drift. So what is continental drift? In 1912, a scientist named Alfred Wegener proposed an idea he called continental drift. Continental drift is the hypothesis that today's continents were once part of a single landmass. Wegener called the landmass or supercontinent Pangaea, and Wegener proposed that Pangaea broke up into pieces that eventually drifted to the continent's present locations. Adding to Wegener's idea was the geologist Alexander Dutoit, and he suggested that Pangaea first separated into Laurasia and Gondwanaland, or just Gondwana. Continued movements then separated the landmasses into even more pieces, and that's what's going on in these pictures here. 300 million years ago, it seems to be all connected. About 200 million years ago, we started having the landmass break apart, first into two big landmasses, Laurasia and Gondwanaland. And then the movement continued until the continents got to their present locations. All right. Well, Alfred Wegener proposed that theory of continental drift, and we know that in science we don't just propose theories because we like to, but we have to have some sort of evidence that points to that being a logical conclusion. So what evidence supports continental drift? Well, Wegener used several lines of evidence to develop his hypothesis. One piece of evidence included the similarities of the shapes of the different continents. He also used climatic evidence and evidence of similar rock layers, fossils, and land features on different continents. So, right now, before we go into those different pieces of evidence, let's go back and highlight what we want to make sure that we pay special attention to. Continental drift is the hypothesis that today's continents were once part of a single landmass. Okay, Alfred Wegener was the one that proposed this in 1912. Wegener called that single landmass Pangaea, which literally means all Earth. Okay. And what pieces of evidence are we going to talk about? Well, he used evidence from past climate, similar rock layers, similar coastlines, meaning the shapes of the continents kind of fit together like a puzzle, land features that were located on different continents. All right. The shapes of the continents. This would be piece of evidence number 1. So people have made world maps ever since they began to travel the seas, and over time, maps began to show more accurate shapes of the continents and oceans. Okay. Abraham Ortelius was the first of the known map makers who noticed that the continents had coastlines that seemed to line up, or that seemed to match up. In the late 1500s, he observed that North America and South America looked like they were torn away from Europe and Africa. Over the next centuries, many others noticed the matching coastlines. So the matching shapes support continental drift because they suggest that the continents were once connected. Okay, so piece of evidence number 1 for continental drift is the shape of the coastline. All right, piece of evidence number 2. We have rocks and fossils. So this is piece of evidence number 2. Fossils of the same plants and animal species are found on continents separated by vast oceans. The diagram on the right, this one over here, shows the distribution of several of these fossils. You have Cynosognathus or something like that. Found fossils of that animal found both on Africa and South America. Lystrosaurus on Antarctica, India, and Africa. Glossopterus Australia, Antarctica, a little bit on India, Madagascar, Africa, and South America. And then you have a fossil Mesosaurus on both Africa and South America. So you have a lot of fossils that you find the same fossils on different continents, and there's really no way that those animals or plants could get from one continent to another the way that the continents are distributed today. All right. So they could not have crossed the oceans that now separate the continents, and because of this, scientists inferred that plants and animals that were alive back then, the continents were joined at that point. Scientists also found matching rock layers of the same age on different continents. Some of the land features on different continents matched up. For example, you have mountains in Western Africa that are the same age and the same composition as mountains in eastern North America, which obviously suggests that that part of Africa and North America were once connected. All right. Go back up here. Fossils of the same plants and animal species are found on continents separated by vast oceans. All right, so we're building our case for continental drift. So far, we have piece of evidence number 1, the shapes of the continents seem to match up. Piece of evidence number 2, we have rocks and fossils that are the same being found on different continents. And then we have piece of evidence number 3 down here that is climatic evidence. Locations of coal deposits and past glacial activity also provide climatic evidence for continental drift. Over millions of years, coal forms from plant remains that die in swampy and tropical areas. Today, we find coal deposits on continents with cool climates, even Antarctica. And this suggests that the continents were once closer to the equator, where they would have had tropical climates. Okay, so we're finding coal deposits in places that the coal could not have been made if the continent was at the location it currently is at. Scientists also found evidence that large sheets of ice called glaciers once scraped over parts of South America, Africa, India, and Australia. Today and in the recent past, these areas do not have glaciers. Scientists explored these areas and found evidence showing which way the glaciers had moved, and the movement only made sense if the continents were connected when the glaciers existed. And that's what is being pointed out over here in this diagram. Okay. Gray areas show you where the areas were covered in glaciers, and it would have only made sense had those areas been connected at some point in the past. All right, so one more time, let's sum it up. Drifting apart. Continental drift is the notion or the hypothesis that today's continents were once part of a single landmass, which Wegener called Pangaea. We have several pieces of evidence. The shapes of the continents that seem to fit together like puzzle pieces. We have similar rocks and fossils that are being found on different continents, and they could not have made the trip across the ocean if the continents were in the place or in the location that they currently are in. And then we also have climatic evidence, for instance, coal deposits in or on continents where we would not normally have coal formation these days because the climate's too cold. And also we have evidence from glacier deposits.